So we had a question the other day about heat treating and the more specifically, what is the minimal that I can use to make a knife? Um, that just really depends on what you want the knife to look like. I mean, you can do it with a file and an angle grinder, but heat treating, it takes some certain stuff that you need to do. So the question that I'll be answering today is how we heat treat. And again, I am no expert, self-taught. Grandfather taught me how to do this stuff a long time ago, but there are certain things that I found out recently that help our process out a little bit better to make the stuff a little bit more durable, more longer lasting and stuff like that there. And I learned that quite a while ago, not just recently, but uh, Grandpa was using dirty oil and it was a haphazard process, and it worked. So first off, what I'd like to talk about is what we use to heat treat. I use propane to heat treat. I forge with coal, and then heat treat with propane because propane gives me a much more even heating, and that seems to be a very important part of the process as far as making a knife stay straight and not causing cracks and giving even tempering throughout the whole process. So tempering will be heat treating is considered in two phases. One, quenching, the other, tempering. Quenching makes the blade hard. Tempering will bring the softness back. So if there's different hardnesses from the quenching process as overheating a certain area or underheating a certain area, then the tempering process won't fulfill through the whole process as well as it should. So we use propane, a dragon breath thing. I think I had some pictures up of it, of using it and stuff like that there. Um, we heat it up roughly, give or take, 1475. Between 1475 and 1600 is, I think, what 1095 is supposed to be used at. We use 1095. It's a really good durable steel, nice for nice for knife making, holding edges, edge retention and stuff like that there. But it's also one of the more forgiving ones for heat treating and for our process of, a backyard forge, basically, for lack of a better term. It's easier to hit the numbers that you need to, causing it to be a quality knife, steel, stuff like that there. So the propane, even heating it up and stuff like that there, and then I'll start heating in the process. So it's not just a matter of throwing the torch to it and getting it hot, and when you hit your number of, so 1420, 1475, give or take. I'm not exactly sure where non-magnetic comes into play, but it's in there. So it's, when it becomes non-magnetic, it's in between that range in the lower end of 1475 to 1600. But the knife blade, I start out with them beveled. I leave the edges a little bit thicker so that they don't get overheated. If you overheat, that'll just grow your grain structure. At any point in time that you see that start a really super bright orange or even white, something like that there, then that's that you've overheated it and you probably ruined that steel on the edge part of it. But you want an even temperature the whole way through. So as Brandon will hang on to it, and then I'll fire the dragon breath, the weed burner propane torch at it, heating more on this side. Like for this particular knife, I'll heat on this side here and watch the colors change in that there through the cooler temperatures where it's what is it, straw, blue, purple, and all them other colors and stuff like that there. And then it'll go to black, and then it'll start turning to red colors, and then you'll watch the red colors come across. If you've done it for a long enough time, you'll see the color and know that that is non-magnetic versus not magnetic. It's sort of like a salmon color. It's not really bright red, but you want it to heat evenly. And as you're doing that, the edge will heat up and become that temperature, but it'll never go above that there, because you're not only just waiting for a temperature, you're actually waiting for something to happen. And I think it's called anesthetizing or anesthetizing. I'm not sure what that word is, but basically is what's happening is the carbon is creating the structure, recreating the structure of the steel, and becoming more uniform. Grain structures and all that stuff are nicer and prettier and stuff like that there. So it's not just a temperature that you're waiting for that process to happen to do that to do. So as the edges are in that temperature range, and then you just keep moving that heat around until you keep the edge good, but building the heat up to this to where this is also hard as well. So when you harden it and then quenching it, I quench it in, and you can see on these they're quenched into about there. So it's a possibility that they're hardened even a little bit up above there. One way to see if they're quenched and stuff like that there is a color transformation that you'll see. I'm not sure if you can see it on these. Some of these other ones are a little bit easier, but there's a gray that you'll see a color transformation. This one here took it really nice and didn't do it. Now here is forge scale. The color changes underneath there, but there's a hardened layer of forge scale on there. But if you scratch that off, you see the color transformation took place underneath there as well. And then, you know, checking it different ways with a file is one of the better ways to check. And you want to hear that skating off. It's not digging in, it's not biting, it's not doing anything to the steel. Now back here it's not hardened, and you'll hear the difference. You can hear how it cuts into the steel. And having it hardened back to here is fine. Having this a little bit it's softer. It's not, doesn't affect the quality of the knife in any way that the whole thing is hardened or not. Tempering process will happen over the whole thing as well and stuff like that there. So once it's heated up, and we wait anywhere from like 5 minutes, 6 minutes, something like that there at that temperature, and then it's quenched in the oil. 1095, it actually lists on there that you can use canola oil. I think Park 50 is the ideal one. We did buy some Park 50 recently. Be truthfully honest, for the price of Park 50, once that's gone, I think I'm going to go back to canola oil. I'm getting the same heat treat, the same process and everything through that. I'm not seeing a huge difference between the Park 50, which is a lot more expensive than the canola oil. Heating the oil up, thermal shock. So like if you would dunk it into, out here in Montana, you know, it's still below freezing in the mornings and stuff like that there. So my oil is, depending on how cold it is, my oil ain't even oil anymore. It's a gel. You know, so heating the oil up, I aim for anywhere in between, I don't know, 120, 140, something like that there, give or take, as long as it's warm. But you don't want it to be over 400, because that's where you're tempering at. So you still want it to cool the steel down, but you don't want it to be that warm that when you put it in there, it's still above tempering process temperature. Temping, let me rephrase that, tempering temperatures. So 150, 140 degrees, somewhere in that neighborhood is where I usually have my quench oil before I start tempering. And then if, like this process here, we've done a lot of blades today. So as you're quenching, you're heating that oil up. So you would probably want to swap out the oil or give it some break so it cools back down and is not overheated and stuff like that there. Most candy thermometers you can have stick in there, and it'll give you an idea for what the temperature is without guessing at it too much. Hardness is, you know, is a process of what is measured by Rockwell hardness. The ideal Rockwell hardness for a knife, you know, you'll get different arguments. Here's the pluses and minuses of it. The lower the Rockwell hardness, somewhere around 52, 55, something like that there, is it'll easier to sharpen, but it'll also lose its edge quicker. Less brittle, you could probably pry with that knife a little bit more rather than cut with it. I mean, if you want to pry with a knife, then you probably should have bought a pry bar. But having a knife with a higher Rockwell hardness, it is a little bit harder to get an edge on it, but it stays on longer. And, you know, toughness wise, like I said, prying, the hardest thing you can ever do with a knife is dig an arrowhead out of a tree. Trust me, I know. I got multiple knives that I've broken tips off, that I've purchased and stuff, and also a couple that I made, I broke tips off trying to dig sideways leverage on a small tip. This is a pretty decent tip, but you know, you get into the pointer ones and stuff like that there, it just snaps that tip right off. which gives you an ideal chance to check out your grain structure, which if it looks like butter or something like that there, you know, it's awesome looking. It's real super fine grain structure is great, which microscopically, you know, gives you a sharper edge because the grains are smaller, so you don't have the in-betweens of the grains and stuff like that there. So the smoother your grain structure is, the tougher your knife will be, plus I feel that I get a better edge on it. And again, I'm sure there's some person that out there that's read all the books and taken a class. I am not a master smith, so there's a classroom discussion that could be debated over it. I learnt from doing. This didn't work, that did work. This works best, this is ideal. Now, I did have an opportunity at the last place that I worked to do Rockwell testing on my knives to see what they were. And our knives came out, you know, give or take in the very high 50s, low 60s, like 59 to 61, give or take, Rockwell hardness, which I think is for my uses of a knife and what a knife is made for, is a good Rockwell hardness to maintain the edge, keep the edge on there as long as you can. So these knives are getting ready to go into tempering. Now, tempering cycles, again, if you look up 1095 tempering cycles, I think what you're going to find there is it's like 400 degrees, 2 cycles of 1 hour. Again, trial and error. I've tested a bunch of different knives and different processes of how to do them, and the best one that I came out with for me, and I don't know if it's an altitude thing, like, you know, for a pressure cooker, you know, but here in Montana it seems to be 405 for 1 hour and 25 minutes. That seems to work best for me, where I get my edge retention and not that brittle that you can do some digging with them, but I mean, that full flexing is not good. The way they are right now, they're very brittle. If I was to try, I may be able to snap them, I don't know, but I guarantee you if you drop it on cement or something like that there, it will chip the tip because they're very hard and brittle like glass right now. And you can kind of hear them a little bit. You know, after tempering, they get, I don't have another knife that's not tempered right at the moment. But you can kind of hear they don't have that same ping that's not tempered versus what is not tempered, heat treated, I'm sorry. The forge scale, there's different ways of tempering out there. I've seen a lot of the non-oxygen tempering where you either put something over it so oxygen doesn't get to it. So the forge scale comes from oxygen. It's an oxidization process that builds up because there's oxygen in the process, and it kind of like builds a little scale over top of it when it goes into that black phase. Whenever you're heating it up, you'll see it'll go into a black phase. The reason that there's different patterns and stuff like that there, you know, it could be oils, it could be something like that there, because if you look real close, you can actually see a fingerprint that was burnt into this one. It won't come off no matter how much you rub it until you sand it through the steel. But right there, it's kind of a fingerprint. So it's sort of like oils and stuff that causes the steel to oxidize or to not oxidize. I'm not really sure. We did a little thing the other day with a paint pen, which surprisingly it kept all the oxygen out of it, so it actually made sort of like a line that you could see on there, sort of like a hormone line. So edit that piece out in there, Brandon. So the paint pen you put on there, it's kept the oxygen out even through the whole heat treating process and stuff like that there. So you could probably make like a hormone line with this paint pen by putting it on there and letting this side do that, and then the other side would be the same. We're going to be going through cleaning these up anyway, so I'm not too concerned about that. There's another fingerprint you can see on there. It's a fascinating process. Like I said, my grandfather taught me how to do it with tractor parts, you know, making like a brake rod and stuff like that there, you know. So too hard breaks, too soft it bends just right, it flexes and does everything that it needs to do. So I hope that answers some questions out there. And if there's anybody else out there, it's one of the things that I like so much about the forging community and some of the stuff that I've gotten involved with and online and stuff like that. There, you always got that guy that knows everything and probably knows nothing, but there's such a sharing of how things are done, and this is what I found is easy, and this is what I found it's easy. You know, so it gives you another alternative of something that you may have not thought of, or how to do it. It's a very primitive way to heat treat. We are looking into getting an oven, which is exacting. You know, so you just beep, 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 and set it, and it heats up and goes through its cycles of tempering and stuff like that there. And, you know, your exact temperatures, you don't have to worry about all that there, exact times and stuff like that there. So, you know, we'll see what happens.